For most of its trip, Voyager has been quietly drifting farther from the Sun than any machine ever built. Then, long after it passed the familiar planets, its instruments recorded something unexpected. The thin solar wind around it suddenly changed character. Temperatures jumped to tens of thousands of degrees, and the spacecraft seemed to brush against a heated layer marking the edge of the Sun's influence. This sounds dramatic, but what makes it interesting is how subtle it actually is. The gas out there is incredibly thin, almost empty, yet it carries signs of a boundary shaped by our star's long breath. Voyager stumbled into a region that hints at where our solar bubble ends and the space between stars begins. It's a reminder that even after nearly half a century, the oldest working spacecraft still has surprises to share. When Voyager 1 launched in 1977 and Voyager 2 ventured beyond the usual planetary neighborhood, they entered a zone where measurement instruments recorded something surprising: a sharp jump in temperature in the surrounding plasma, reaching about 30,000 to 50,000 Kelvin, roughly 54,000 to 90,000 degrees Fahrenheit. This region isn't filled with fire or flame in any ordinary sense. The particle density is extremely low, so even though the temperature, a measure of particle energy, is very high, there's hardly any heat transfer to the spacecraft Indian Defense Review. The jump occurs at a distance where the outward flowing solar wind begins to give way to interstellar space, roughly where the boundary called the heliopause sits. In practical terms, what Voyager measured were very energetic particles and a magnetic field environment that changed suddenly. These changes mark a transition between the Sun's influence and the surrounding interstellar medium. The discovery is remarkable because it gives us direct in situ data from the frontier of our solar bubble. Rather than relying purely on models, we now have actual spacecraft readings. The phrase sounds like something out of a sci-fi story, but it came from scientists trying to describe a sudden change in the environment around the Voyagers. As the spacecraft pushed outward, they moved from a region dominated by the Sun's wind into a place where that wind slows, compresses, and heats up. When particles get squeezed like this, their energy rises. In technical terms, the plasma temperature shoots up. In everyday terms, it feels like running into a hot boundary. Calling it a wall helps capture the idea of a sharp transition, but it is nothing like a solid barrier. There is no surface, no glowing sheet, and no danger of the spacecraft melting. The temperature figure refers to how fast the particles are moving, not how hot it would feel to the touch. The gas is far too thin to carry heat the way air does near Earth. The fire part is just shorthand for that high energy. Out in this region, a single cubic centimeter might hold only a handful of particles. Even if those particles are extremely energetic, they transfer almost no heat. Voyager drifted through this area without any special protection because there was simply not enough material to cause harm. What makes this region interesting is the way it shows the Sun interacting with the wider galaxy. The solar wind pushes outward for billions of kilometers until it finally gives up against the thin flow of particles drifting between the stars. The heated layer forms right where that slowdown happens. It is a signpost marking the boundary between two very different environments. So the wall of fire is really a shift in particle behavior. It looks dramatic in a headline, but in reality, it is a quiet and almost ghostly frontier. If you picture the Sun constantly blowing out a thin stream of charged particles, you can imagine a bubble forming around our entire planetary system. That bubble is the heliosphere, and everything we know as the solar system, at least in terms of space weather, sits inside it. As the solar wind races outward, it eventually loses momentum. Far from the planets, it slows, thickens slightly, and becomes more turbulent. That zone is the heliosheath, and it's where both Voyagers spent years sending back data. The heliopause is the outer edge of that bubble. On one side, particles still carry the imprint of our Sun. On the other side, the particles come from the galaxy itself. Crossing it doesn't feel like stepping through a door. It's more like drifting from one kind of thin gas into another that behaves differently. But for scientists, it's one of the most important boundaries in the entire solar environment. Voyager 1 reported its crossing in 2012, and Voyager 2 followed in 2018. each spacecraft recorded a sudden shift in the direction and intensity of charged particles. They also detected a stronger magnetic field outside the bubble, shaped by the surrounding interstellar medium. These signs told researchers they had reached a place where the sun's influence truly fades. Understanding this boundary helps explain how cosmic rays enter our region of space and how the sun shields us from part of that radiation. It also gives clues about what similar bubbles around other stars might look like. Until the Voyagers arrived, everything about the heliopause was based on theory and indirect evidence. Now we have direct measurements gathered by two aging spacecraft that were never expected to operate long enough to see this frontier. The edge of the heliosphere might seem remote, but it shapes the conditions that every planet in our system experiences. The sun constantly releases energetic particles, and the heliosphere acts as a shield that softens what comes in from the galaxy. When Voyager reached the outer boundary, it showed how that shield actually works and how much protection it provides. The temperature spike the spacecraft detected helps scientists understand how particles behave when two different environments press against each other. That information feeds into models that predict everything from space weather to radiation levels around future missions. If we ever send probes or crewed craft well beyond the planets, knowing how the solar bubble interacts with interstellar space will matter for planning and safety. There's also a broader benefit. Many stars create bubbles like ours, each shaped by its wind and motion through the galaxy. By studying our own boundary directly, researchers can better interpret what they see around other stars. It turns the Voyagers into a kind of calibration tool for understanding stellar systems in general. Closer to home, the data helps refine how we understand cosmic rays. These high-energy particles can affect satellites and electronics, and they play a role in long-term mission design. The readings from the Voyagers show where these particles slip into the solar bubble and how the sun's activity changes that access over time. What makes all of this remarkable is that the information comes from spacecraft designed in the 1970s. They've become our only observers in a region where no other mission has reached. Their measurements don't just describe a distant frontier. They help us understand the environment that has quietly shaped Earth's neighborhood since the solar system formed. Voyager's glimpse of that heated boundary reminds us how much of the solar system remains uncharted. The spacecraft didn't see a wall in any ordinary sense. It sensed a change in behavior that marks where our star's influence tapers off and the wider galaxy begins. That quiet transition, recorded by hardware built decades ago, shows how much discovery can come from simply staying the course. Even though both Voyagers now travel through interstellar space, their signals still shape how we picture our place in the galaxy. They turned a distant theoretical frontier into something measured and real. It's a reminder that exploration doesn't always look dramatic. Sometimes it's just a slow drift into the unknown, guided by instruments that keep sending back stories long after we've stopped expecting them. If you want more science explained simply, stick around.